Hello class, welcome to the lesson of New Energy Vehicle Motor and Control System Maintenance. Today, we will introduce the structure of the electric vehicle powertrain system. The driving energy source of internal combustion engine vehicles is the engine. Considering energy security and environmental safety factors, initially, electric vehicles were developed and adapted from internal combustion engine vehicles. Electric vehicles mainly consist of the powertrain, onboard power supply, and auxiliary systems. Today, we will focus on the powertrain. Firstly, we should know that the powertrain of an electric vehicle consists of the motor drive system and the reducer. The motor drive system is one of the three core components of an electric vehicle and is the main executing mechanism for driving the vehicle. Its characteristics determine the vehicle's leading performance indicators and directly affect the vehicle's power, economy, and user experience. The motor drive system consists of the drive motor and its controller, which are electrically and thermally connected to other systems in the vehicle, through voltage limiters, cooling pipelines, and other components. The drive motor is electrically connected to the motor controller through UVW three-phase high-voltage cables and mechanically connected to the reducer through the output shaft to convert electrical energy into mechanical energy and drive the vehicle. Meanwhile, it collects data about its operation through the built-in rotary transformer and temperature sensor, sending the data to the motor controller through low-voltage limiters. The motor controller consists mainly of an inverter and a control board. The high-power battery provides DC power, which is inverted into three-phase AC power with adjustable voltage and frequency to drive the motor. The control board processes all input signals and sends them to the vehicle controller through the CAN network. It adjusts the output of the drive motor in real time to achieve functions such as idling, moving forward and backward, pulling up, energy recuperation, and parking. On the other hand, the motor controller performs real-time status and fault detection through current, voltage, and temperature sensors to protect the drive motor system and ensure passenger safety. The electric water pump and the low temperature, low pressure cooling liquid are successively sent to the radiator through the motor controller and the drive motor to dissipate heat by airflow. When the temperature of the drive motor reaches 45 degrees Celsius or the motor controller reaches 75 degrees Celsius, the VCU controls the cooling fan to speed up the airflow and cool down the cooling liquid, ensuring the regular operation of the drive motor system. The motor controller is controlled by the Vehicle Control Unit, VCU, through the low voltage battery to the VCU control. The relay and fuse supply power to the motor controller while communication is carried out through the CAN network. There also needs to be signal transmission between the motor controller and the drive motor. The motor controller needs to collect feedback on the rotor position and temperature signals of the drive motor and send them to the VCU. Next, we will learn about the relationships between the various components through the drive motor system structure diagram. From that diagram, we can understand the flow of high voltage power in the drive motor and data exchange between the components carried out through the CAN network, the role of low voltage power supply, and the circulation process of the cooling system. That's all for today. Thanks for watching.